Hello everyone, and welcome to our 14th Quantum London webinar. For everyone who's new here, a few words on Quantum London. We're a group of professionals from different industries who are interested in understanding the business implications of quantum computing. We do this by running webinars like the one tonight, as well as hosting more informal sessions where together we discuss new things happening in the quantum world. Links to all our social media channels are on the right, and you'll be able to get more updates on the events we host. So today we bring you another very exciting talk, which in fact fits very nicely with UK FinTech Week. Today's talk is a second session of a two-part series we are running in collaboration with CR Partners, looking to explore how business advantage can already be created by quantum computing. We'll be looking at commercially relevant applications and continuing the excellent discussion from last session about hybrid quantum and why it's important that executives and technologists across various industries realize the opportunities quantum computing can offer right now. And most excitingly, we'll be able to hear from the experiences of our fantastic speakers and their own quantum journeys. So our speakers for tonight are Stephen Nundy, partner and CTO of Lakestar, who previously worked at Goldman Sachs for 20 years and served as managing director. And joining us again from last session is Markus Pflitsch, CEO and co-founder of Terra Quantum and a CERN quantum physicist. Markus was also previously investment banker at Deutsche Bank. They'll be joined tonight by Vishal Shete, Head of Quantum and Value Creation from CR Partners, who'll be facilitating the discussion. Vishal was also previously the COO of an investment fund. CR Partners, who are running this event series in collaboration with, are focused on inventing the future with the power of quantum computing. They've recently launched a dedicated quantum lab that provides strategic and technology advisory services and supports the creation of application-specific business advantage across different sectors. During this session, there'll be the chance to ask questions in chat on the right-hand side. I have with me here today Paolo, one of the co-founders of Quantum London. We'll be moderating questions throughout, and we'll have time at the end to put your questions to our speakers tonight. So without further ado, I'll hand over to Vishal to start the session.
Thank you, Anahita. Such a pleasure to be here, and such a pleasure to be joined by Markus and Stephen at this panel as well. Markus and Stephen, great to have you here. It would be great to hear a little bit about yourselves and your experiences before we dive into what quantum can do in financial services today. So Markus, you've got a remarkable amount of expertise, skills, and knowledge both in quantum computing and in financial services. Would be great to hear kind of how did you go about kind of gathering this remarkable knowledge base?
Well, actually, thank you, Vishal, for the invitation. So very happy to be here again. I think it's a great series of webinars actually on quantum. Well, how did it come that I'm potentially qualified for quantum in financial services? It's actually by my education, I studied quantum physics and maths and worked in quantum field theory at CERN in Geneva, actually back in the 90s. But then switched to a normal kind of business career, went into strategy consulting at Boston Consulting Group, and then into banking. So kind of I did both, so to say, and therefore potentially can look at those use cases and adoptions of quantum in financial services from a special angle. Yeah.
Fantastic. And so, at what point did you realize that this is the time to bet my career on quantum computing? What time was that? Was there a moment when the penny dropped?
Well, I mean, actually, I was always passionate about quantum since I was a teenager, so I never lost kind of that passion. But when I left kind of academia, I just kind of followed it as a hobby. But actually, 3 years ago, I reminded myself of actually something which Heisenberg claimed. The sum is more than the parts, yeah. And actually, I said, let's combine kind of my, let's say, quantum physics brain side together with the corporate finance side within my head and commercialize on quantum. Because I think back then it became clear, at least that was my feeling. It is not a question of if quantum computing will kick in and will bring a big disruption. It is just a question of actually when it is kicking in. And I think, looking back, it was a perfect timing because I think we see kind of a increasing dynamic in the space.
Super interesting. So what about you, Stephen? What was your first encounter with quantum computing and when did you realize this was something to be taken seriously?
Well, I think just to build upon kind of my story and how I've got to here, like I'm an investor now, but I'm a computer scientist at heart, and so I spent 4 years at university learning how to write code and how to build systems, and then end up spending 20 years at Goldman as an engineer in a number of different business areas. I lived in Japan for 5 years. I wrote the first line of Java code, and towards the end I was running significant parts of the organization globally and regionally here in Europe. And I think if I just take a big step back, when I was at uni, I thought like many of us, we were learning about new things. We were learning about artificial intelligence, which didn't exist in the world at the time. We were learning about grid compute and this notion of a cloud that might exist in the future, and everything's going to be streaming. We talked a little bit about quantum at university as well. And there was all these things we learned about university. When I turned up at Goldman, we kind of then I had to reset myself as to, well, now let's move into the practical world. This is what technology we have available, and this is how we go and build stuff. And so the first few years I was at Goldman, I was, Java was like avant-garde. That was the latest thing that had come out. And so writing, not having to use Microsoft was kind of cutting edge then. And then suddenly you start thinking about grid compute, and we started building our own grid networks. Then you started realizing actually there is big data. Big data really does mean machine learning. And then we start thinking about, quantum started coming in towards the end of my time there. And these are all technologies that you've heard about in the abstract, but have now started making mainstream. And so for me, quantum in the last 5 years, and certainly in the last 2 or 3 years I was at Goldman, started becoming a serious topic in the same way as grid compute became a serious topic 15 years ago, and AI and ML became a serious conversation 7, 8 years ago. Quantum is now a serious topic. And so that's what got me excited, because you start seeing these cycles as you get older. You see these cycles starting to emerge, and you realize what those signals are for something that's a wave that is really about to crash over us.
Yeah, absolutely. And what was that moment when you realized at Lakestar that this is coming, and this is something that we need to be investing in? Was there one particular moment that made you kind of sit up and take notice of this, or was it all about making a judgment call on when's the best time to jump in?
As if I put as an investor, it kind of feels that we are now very much touching distance away from seeing some real commercial use cases being adopted and actually delivering value back. So as an investor, that's when, for us anyway, at Lakestar, things become interesting. We are a multi-stage investor, but we are certainly an investment team that really gets excited when we're getting close to a commercial outcome, where there's a go-to-market, where there's truly revenue that is kind of reachable for both the customer or the producer of the technology. And so when I sat back a year or so ago, year and a half ago, at the partnership meeting, we talked about what's our strategy over the next 3 to 5 years. And I presented deep tech. Quantum to me was logical as an area that we needed to get exposure to as an investment company, as a fund, but for many different reasons. But some of that was certainly shaped from what I was seeing as in the last couple of years I was at Goldman, and then seeing the market mature and seeing some of those use cases starting to get to prime time. And I think also just, as an investor, you have to position yourself with a 5, 10 plus year outlook. And so now felt very natural.
For sure. So I guess rolling back the years a little bit into your time at Goldman's. So when you were there, what was kind of your motivation in terms of exploring the quantum landscape? So it would be great to hear about some of the work that you did in that space. What is your motivation to get started into that space?
So Goldman's a massive company, 35,000 people, 7,000 engineers. And so by and large, it's a technology company. It's also a very complex company, and if you just take one of the areas that I was responsible for, which was treasury, one of the teams I looked after was corporate treasury. Goldman has 2,000 entities around the world. Any one of those entities at any one point in time could be holding euros, dollars, sterling, or Japanese yen, the 4 major currencies. And every single evening, the bank needs to decide what to do with each of those currencies. Is it going to hold more or less of it? And that's going to be a function of how much trading activity is going on at the time, what the regulators are saying in terms of how much capital you need to keep in one place. How much does it cost to actually move cash from entity A to entity B? And so there's a whole number of factors that came into how you optimize for where you keep cash on an overnight basis. And then when you add into that it's a global world we live in, the end of day in Tokyo is different from the end of day in London, different from New York and from the West Coast. And so you've then got a time zone aspect to this as well. And so that's a massive challenge. And the optimization of that, we were managing through rules. And as a result, we knew that we were leaving a lot of opportunity on the table because the rules could not keep up with the complexity of the optimization that we needed to deal with. And that's when we really started thinking about whether there was another solution, and obviously quantum raised its hand as a potential option there.
Super interesting. So it was very much problem-led and not, this is a problem, I need to find a solution. One of those solutions could be quantum, not let's do something with quantum, what can we apply it to, in terms of how you thought about it.
Exactly. And then at the same time, there was we were looking as a firm at D-Wave and 1Qubit as investments. And so there was a natural marriage of interests in understanding from an investment perspective whether there are real use cases. And at the same time, we had real use cases we're looking for solutions for, and was like, well, is quantum a solution that we could meaningfully consider at this point in time?
And what was the journey to talk to the rest of the organization about quantum at this point, with this use case and otherwise, and then with the D-Wave and other investments? How did you bring it up with your peers and others in the organization?
I think I think this is where we were hitting. We started hitting some challenges. Again, I'm rewinding the clock now 4 years or so. When you realize that actually, having a conversation is great. But if you have a conversation, you just become a talking shop, and the technology is not ready to implement these great ideas, then people get frustrated. And an organization like Goldman, like many fast-paced organizations, people want to have a conversation and then see an action and an outcome very quickly thereafter. And that's where we started hitting roadblocks 4 or 5 years ago, when we realized that actually the technology wasn't quite there yet. The organization wasn't quite ready yet to take on board this kind of revolutionary way of thinking and working, because actually there's some practical issues, organizational issues that need to get impacted as well. And so what started off as a very interesting opportunity ended up being snowballed because of some of these other factors. Again, this was 4 or 5 years ago. And I think that's where I'm excited now, because it kind of feels some of those issues have now been resolved. And so now kind of the abstract view that we're not ready for quantum is a 3, 4, 5-year-old view, when the reality is today that actually there are practical applications that are now ready for quantum.
Super exciting times indeed. So switching gears a little bit to Markus. Markus, just on that note, I know with Terra Quantum, there's a lot of work that Terra Quantum does in hybrid quantum computing. And that's kind of been, one of the core focus areas of your firm. Would be great for the audience and for ourselves, just to hear a little bit about what is hybrid quantum computing and what's your take on it with Terra Quantum.
Yeah, so let me kind of elaborate a little bit on it, and I think it actually also starts at the corporate end, because corporates today, I mean, we hear a lot, there are, so high entry barriers. How do we get started with quantum actually? They usually don't have a quantum architecture, quantum machine. I mean, how could they? There aren't too many, offerings out there in the market. But they are acquainted and familiar with high performance computing, right? Most of the kind of big data sensitive and intense applications run on HPC architecture. So that is kind of well known how you use high performance computing, with kind of classical algorithms. And then on the other kind of extreme side, you have kind of a pure play, which is, you have a pure quantum algorithm and you run it on one of the selective quantum machines which are available in the market, on a true quantum computer with kind of true qubits. But actually, that will potentially not be the future. We'll see an intelligent combination of both sides. You will have a combination of mixing high performance computing architecture with quantum computing architecture. And that's actually what we call hybrid quantum computing. So it's a process of using both quantum and classical computational resources in problem solving. And therefore also a hybrid quantum algorithm combines both quantum and classical operations. Each that together these operations lead to a problem solution. Yeah, and both quantum and classical algorithms have advantages and weaknesses, but in different ways. And given a use case, our goal is then to design a quantum algorithm that solves the classically intractable problem, and where no quantum weakness are present due to a classical algorithm support. Yeah. So for that reason, in many use cases, which we actually see, and I think we'll talk about some of them later today, hybrid algorithms actually outperform pure quantum or pure classical algorithms run on supercomputers. So the perfect combination is actually what yields to better results. And therefore at QMware, we do hybrid quantum computing. How do we do that? We, in the moment, because, the quantum resources and qubits are very limited. Therefore, we have virtualized qubits, virtualized on an HPC structure. And with that, we can show a performance of 40 qubits without any noise. And that is a very powerful machine where you actually can deploy hybrid quantum algorithms, which show a quantum advantage actually compared to the classical solution. And that is by intelligent design of quantum and classical algorithms.
Interesting. We like to say sometimes on the say partner side, we like to say sometimes the path to quantum, is not binary. So there's kind of a lot of steps that you'll be taking along the way. So no, absolutely. So question for both of you. A lot of times corporate executives today, they have a mindset that, before I explore quantum or, sometimes even before I explore machine learning or any of these advanced technologies, I need to sort my data out first, right? I need to make sure that my data is in the best place possible before I look at any advanced analytics opportunities. What would you say to these corporate executives? Are they right?
You're on mute, I think.
Take a quick stab at that first. One of the roles I held at Goldman was we built the first data lake at the company back in 2013-14, and one of my teams was running the functional architecture on top of that, the functional ownership of the ontology and the business models that we were putting into the data lake. And so we had this forever conversation about quality of data, source of truth, etc. And the real answer is that what we discovered and what we know as a corporate is that the data is never fully clean. Data always gets dirty. Data always needs cleaning up, and it's a constant battle, right? And so I think you need to then kind of figure out, well, what is it you're trying to achieve? If you're trying to achieve something that is of regulatory significance, or you're dealing with someone's bank account, or you're dealing with a record where it absolutely has to be, the precision has to be, to the fifth decimal point, then clearly that's where you should focus your time and efforts to make sure that the data is absolutely clean. If you're looking for optimizations, or you're looking for, the ability to look for patterns in large data, or you're looking to build a model that is not going to be perfect, but it's going to be a much better model than having 10 humans try and do it manually, then you can work with imperfect data. I think you just need to understand where, how imperfect your data is. It doesn't, if you say, well, my data is ballpark accurate, or I know that perhaps 5% of the data is inaccurate, and you just bake that into your assumptions as you build your models, then these models can always run again and clean themselves up and continue to iterate and improve. And actually, a lot of model improvement is actually in the model itself, not in the underlying data. You can continue to clean the data, but the approach you take to building a model, or the logic that you apply to solving a problem, the algorithm, has as many errors or inefficiencies in it as perhaps a data unit being out by 3%, 5%. in the grand scheme of things. And so I think you just need to take that step back and say, well, do I really need completely precise data to be able to achieve a better goal tomorrow than I've got today with imperfect data? And typically, I think you can.
So again, it's kind of a problem-specific decision-making there, right? So in some areas, some problems, as you say, it's impossible to work with data that's noisy. But in some instances, you should be able to do that and do that effectively.
Exactly.
Yeah. Any thoughts on that, Markus?
Well, no, I would absolutely agree to that, and would like to add that also from kind of a, let's say, strategy perspective, I think the time really to start is with quantum is now, yeah, and we see that I would say 80% of the large corporates say we have to get started with quantum. I see other kind of barriers actually to get started. Which are, how do we get started? We lack the human resources, kind of the quantum physicist. We lack kind of the hardware to deploy something. And actually, we, want to avoid kind of capital intensive activities in that early stage technology when we get started. And that's why actually we, with the Terra Quantum Group, together with QMware, have created an kind of integrated business model to address actually those entry barriers for corporates and lower them in the way, that we really come in, look at the use cases of those corporates. And by now, I mean, especially if we talk financial services, I think there are multiple use cases which also corporates know, which, should show a speed up if you migrate to quantum, and help them, with these use cases to transform that into quantum algorithm with our own talent and people. So they don't need their own quantum physicists to do that. And also we bring our own machine, which is the hybrid cloud, QMware, where they can deploy those algorithms which we develop together with them. And that in total is an offering, which has low entry barriers to get started, and I think that's another major aspect here, which we often hear. And actually, I think that is then the right strategy to get started into this, as it's such a disruptive technology that you just can't wait.
Yeah. I mean, it's a really good time to be having this conversation with two professionals with incredible experience in financial services in the middle of UK FinTech Week. So it's an exciting time to be talking about that. So on that note, maybe let's dive into financial services in a bit more detail. So from both your perspectives, it would be really good to hear what do you see as the most impactful applications of quantum in finance in the near, medium, and long term.
Well, I think I spent 15 years working with hedge funds at Goldman, both in terms of I was running risk platforms within the company. So every night we were stress testing 1,500 hedge fund portfolios, looking for outliers, looking to shock those portfolios against potential market events. Mm-hmm. And we had to take shortcuts when it came to how you thought about repricing a derivative, how you thought about repricing a credit instrument, because these products are very expensive to recalculate from first principles every single night. And so we used to take the approach where at the weekends we would do a full refresh, and in the week we would take an opportunistic or optimistic view on repricing some of those instruments based on volatility in the market at the time. Again, so I with quantum, the ability for you to do deeper repricings on a daily basis will be there. So that's one internal risk model. If you are a hedge fund yourself and you're a quantitative hedge fund, you're taking in many inputs when you think about looking for macro opportunities to invest. And so again, you're dealing with large data sets, large input variables, wicked problems where there's no rules-based potential solution. And again, that's where quantum in terms of annealing can come up with optimization opportunities for you to think about the balance of your portfolio. So I think it's, and I've already mentioned the one about collateral optimization, where you've got billions of dollars in various currencies floating around the organization. Where do you put that cash on an overnight basis? Incredible amounts of wastage. So if you think about these bigger existential problems, I think they're the first ones where quantum may be helpful, where they will provide an advantage over your current kind of process approach. But there's going to be more. But I think back to Markus's point, if one of the challenges with any new technology is access to that technology, right, and the barrier to entry. And not every organization is going to be able to afford to have a team of 10 or 20 people go off and quote unquote learn quantum, and without a good use case. But we all learned machine learning. We all kind of learned blockchain a few years ago. Every man and his dog built a blockchain in their garage over the weekend and launched a coin, right? Why was that? It's because the cost of entry as a developer was low, right? You could actually go and muck around with this stuff because there was courses, there was open data, there was open source, cloud was very cheap, and so you could go and experiment, and you didn't have to call up your CTO or your husband or wife to ask permission to spend a ton of cash at the weekend to go and self-learn. I think quantum needs to get to that point, right? It needs to get to the point where the barrier to entry is low enough where people aren't afraid to experiment. Because with experimentation, you'll then find innovation and new ideas. If the barrier is always seen as very high, people will not take that leap because they'll be afraid to do that. And so that's the piece that I think is that we should be focused on as well, is do we think the barriers are low? Do we think they're going to get lower? And therefore, how do we encourage corporates to start the experimentation process early, even if they don't have a fantastic use case just yet? They just want to get educated and they can afford to get educated.
And do you see those barriers lowering at the moment? Like what's driving them lower?
Well, I think this is where my relationship and meeting Markus and understanding what QMware are doing, I think is where things get interesting, because if suddenly you can say I get access to something that smells like a quantum machine, looks like a quantum machine, but isn't quite a quantum machine, but I can do some very valuable things and I can turn that on and off and get access to it in a secure way at a price point that makes sense, then I should be experimenting. I don't see this as a mega capital outlay that I need to go up to, the procurement team and board level sign off. This should be something that becomes lower. And I know IBM have done a great job of giving access to the IBM machines, the simulators in the US. They're low powered machines, low qubits. And ultimately, again, you're sending your data across the continent, across the Atlantic to a different place. And depending on what you're trying to achieve and what you want to experiment with, again, there's only so much you can experiment with if you're sending data outside of your organization or into a continent where you've got information security concerns. And so again, we need to bring down the access to this technology to a regional or a country level as well before we get to a corporate level. A corporate level is obviously ideal, but there's other barriers there too, which are physical, not just economical.
Fascinating. What about you, Markus? What do you see as the most impactful applications in financial services, and over what time frame?
Yeah, I mean, that's of course, that's kind of a very, very detailed question, so to say. But let me first give some kind of highlights, and then I would also kind of tackle one specific use case in more detail. So I actually see that, within asset pricing and portfolio management, we see a lot of good use cases, because those can be reduced to an optimization problem, and that is very achievable for quantum. Besides that, option pricing, I think is a big use case. Quantum enhanced cybersecurity, fraud detection, risk management, but also in the credit space, credit scoring, credit analysis, or loan selection are areas which we could discuss deeper, or some of them probably later. But let me touch on one, which is the collateral portfolio optimization, which actually is a mission critical application within large investment banks. They typically have a collateral portfolio of 400 to 500 billion. If you take the European investment banks, the big US banks potentially have a trillion in portfolio size. And if you actually could optimize that process just for a few basis points, that has tremendous impact based on the portfolio size. And actually, what we did here is already some work where we could really show that you should get started with quantum, especially in financial services, and not just because, to learn and have a kind of intellectual kind of playground, but really to address business performance. So in that example, what we analyzed, kind of the data set we analyzed, we looked into all of that, and in total, if we combine all asset requirements and constraints, we had more than 1 million discrete variables to look at. Yeah, and that's really tough problems for classical solvers. To give you a picture, a last generation of D-Wave machine allows to tackle problems with less than 70 variables due to the limited connectivity. And our solution on collateral optimization is powered both by the replication of quantum algorithm in high performance computing environments, so on our machine, and unique quantum optimization approach. Moreover, we implemented the efficient post-processing that ensured really the feasibility of the quantum solution. And our algorithm is then suitable for noise intermediate scale devices. Efficient classical subroutine hides the imperfection of the quantum device. And we also outperform other quantum approaches such as quantum annealing or quantum approximate optimization algorithm, because we have much more efficient encoding of classical data in the quantum state. So that yielded then to a result where, with a hybrid quantum algorithm approach, we could show a couple of basis points improvement on the portfolio size. Yeah, and that translates into a 3-digit million euro annual recurring cost saving just by migrating that specific use case on collateral portfolio optimization into the quantum space. And I think that are the use cases we have to tackle, because that has business value. That is, you don't have to convince kind of the CFO on that one, even if the kind of strategy officer says, we have to get started with quantum. This one is great, because it saves real money. And that's, I think, where we should look at. And besides the collateral case, I see, various other potential use cases which show a quantum advantage already today if we tackle that in the right way.
That's super impressive. I mean, that's super impressive when you can show that kind of business advantage. I guess one thing to consider is when you're looking at 1 million decision variables, like you said, it's not just binary decision across those 1 million variables. It's kind of a, it's in a way a non-discrete decision across all of those, right? So you need to, how much to allocate across each of these 1 million decision variables is a pretty complex solution. So that, when D-Wave or other annealing machines, that you talk about the variables they can look at, it's typically binary optimization that they do, whereas this is, it's even more complex because it's non-binary. Yeah.
Absolutely. Yeah.
So for both of you, another kind of controversial question. There's this talk about the quantum winter, and every so often you see some articles published from industry observers that that there's a risk or there's a possibility of a quantum winter coming. What are your views on this as an investor, as a CEO in the quantum domain? Do you see this as a real potential risk, and how would you handle it?
It's it's interesting. It's quite sensationalist sometimes to talk about these things. I think everyone's got used to the hype curve, right? That we talk about all the time. That's been kind of well coined, and you get to the trough of despair, then everyone comes out the other side, and the question is, where are we with quantum right now? Yeah. Certainly on crypto and blockchain, you could argue we've gone down the trough and we're starting to come back up the other side now, right? But is it a winter, or is it more? We were chatting before this event. Is it more of an autumn, right, where things slow down a bit, the leaves turn a bit brown, some leaves fall from the trees, and then suddenly there's a second spring, right? So I don't think you're going to see a winter. I do think that you're going to see, as with all technologies that emerge, a slowing down as people take stock, as people then catch a breath, see where the quality is, see where the use cases that are really working are, and then people start moving forward again. But time will tell. But people talked about there being an AI winter. People talk about being a blockchain winter. People talk about these winters all the time. And if I look at the last 15 years, I haven't seen them come. And what we have seen is we've seen global crises, we've seen pandemics, we've seen other things that have existentially kind of impacted society or impacted business. So who knows what the future's gonna have? But I'm not considering a quantum winter coming up. I think things will slow down, things will speed up again.
Interesting. What about you, Markus?
I do agree. So I think quantum is such a substantial disruptive technology. Yeah, and we see. I mean, we now talk more focused about financial services industry, but we see relevant use cases, which deliver value today already. So therefore, and it will be so much more in the future. That whether this takes kind of 1 or 2 years longer, so to say, until you have a true mature QPU, which is performant, is not so decisive. I think the big corporates, are getting started now with this because it is so disruptive, and you have to, and you have to have a position into that technology to defend your business model. And I think if you look more into the quantum tech space, I mean, if you are purely kind of hardware R&D focused, this might be a little bit a longer kind of journey until you come up with a QPU who has kind of great performance and enough qubits. But exactly in that NISQ era, the noisy intermediate scale quantum computing era in which we are right now, I think hybrid models are what you should approach, how you should approach quantum. And then there is no quantum winter, because that will definitely not only bridge the gap, actually, it's there to stay, because you always will have that intelligent combination. But especially now, if you work with virtualized qubits, which have no noise, and have with 40 qubits, for instance, have a power that you can execute on relevant use cases, then this is a perfect method, I think, to develop your algorithms on the various use cases, deploy them on the machine. Take the collateral case, you might, benefit in the moment with a 40 qubit machine with, let's say, 6 to 10 basis points on the portfolio, and in the distant future, if you have a more mature QPU, it could be even 20 basis points or 30 basis points. But you can get started, and the application you have developed is there to stay. That quantum algorithm can be used not only, e.g., on our virtualized qubit machine, but can also be applied on other QPUs in the future. So therefore, that work, what you do now as a corporate, is well invested, because you tackle the relevant use cases, you develop solutions on the software side, on the algorithm side, and then you just, benefit from the increasing performance with the maturity of the QPUs which become available.
So Markus raised a good point. I just saw in the chat actually from Emmanuel asking, have we even seen the spring yet? And maybe that's a really good point. Maybe we're not even in the quantum summer, and we're talking about quantum winter. And maybe arguably we're only just seeing the first buds of bloom in the spring, right? So let's not get ahead of ourselves. But I think to the point that Mark said, some of these early applications are, if they're going to be, the accessible, then it's probably going to be in the optimization space, right? And so if, for example, the classical optimization kind of use case that we keep on talking about, and the optimization that your quantum algorithm comes back with is that you should move, you should instruct, 342,000 movements of cash, you're not going to do it, right? You physically cannot then execute the recommendation from the engine.
Yeah.
So there's actually a trickle-down effect. Having an algorithm that produces an optimization is great, but then the mechanics of the financial system, or any system that sits underneath this recommendation engine, is it ready to execute every single recommendation of the optimization output? Probably not. So then you're going to take little baby steps. You're going to say, well, you know what? I'm going to do this once a month, and I'm not going to do all 324,000. I'm going to do the biggest 50,000 that makes sense, but I'm only going to do it once a month, because it's still worthwhile me manually or through other processes getting some of that optimization value out. And you know what? Next month I'll rerun it, and I know that between the 30 days that elapse, I'm building more inefficiency back into my system again. but that's okay because I'm still getting advantage once a month as part of like a house cleaning exercise.
Yeah.
And then you'll go to doing that on a weekly basis. Then you'll go to doing that on a daily basis. And then at some point in the future, when we've all got 50 qubit machines in our pockets, right, we can do this on an hourly basis or a minute by minute basis. But no one's suggesting for 1 minute that we're going to have real-time quantum optimization of collateral across, significant size investment banks or the financial system. But you have to start somewhere.
Yeah.
And I think if it's easy for us all to say, well, until we've got this utopian view, we shouldn't even bother looking at the algorithm because the mechanics can't deal with the algorithm. And I say, no, you've got to look at both in parallel. And until you find a reason to build the mechanics out to be able to deal with the frequency of recommendations that quantum can provide, you need to work on both in parallel.
Yeah. So it sounds like for corporates, the way to hedge that risk is by taking baby steps and getting started, taking small steps at a time, while also, using technologies like hybrid quantum to kind of reduce the risk of the technology development that is still happening.
Because quite honestly, Vishal, it could well be like the cost of you trying to develop an algorithm, come up with an optimization, and then even getting humans to manually move the assets around.
Yeah,
you'll still get a return on that investment.
Yeah.
It's going to be multiple times the cost of the development team and the hybrid compute access that you purchased. Yes, it's not repeatable yet. Yes, it's not industrialized yet, but you've proved it out. And that's a milestone unto itself that allows you to then start building bigger programs of change within any organization.
Yeah.
Just one more thought here, and in a way, it's also, in some other areas, good that we don't have yet so powerful quantum machines, up and running. I mean, I just want to touch quickly on the cybersecurity space, which is also very important for financial services players. I mean, the digital exchange of your data should be, absolutely secured, right? So we do know that there is a threat of quantum computers with kind of classical encryption codes. So work on quantum cryptography, making your organization really post-quantum secure already today, because once that computer is there, the threat is there. You should use the time now wisely to prepare your organization to be truly post-quantum secure, and that's some important work also in the cryptography space, which has to be dealt with now.
Yeah, that's a very real risk, right? Like potentially some of the data that's already been created today is already at risk of being, at the risk of there's some security risk to that through something that will come about in the future because the data is already here today. So yeah.
Exactly, and as you don't know exactly when that day will come, when that machine is there, you have to prepare the organization now, so that vulnerability is disappearing. Absolutely.
And can we already prepare that? Like, can we already be quantum secure today? Is there a way of ensuring that happens today?
Yeah, well, actually, there is. I mean, there's a lot of work going on to develop truly post-quantum secure protocols, right? Because more and more, and that's also some work we do. Actually, we see that protocols which have been reviewed as being really post-quantum safe or robust aren't so robust actually, but can be show vulnerabilities with a performant enough quantum machine, and that's part of our work, and therefore we also have created a new encryption protocol based on fast quantum key distribution, which is totally implementable over the traditional optical fiber infrastructure, which would be post-quantum secure, or actually is post-quantum secure. Also, it can't be hacked by a true universal quantum. So there is relevant work going on and protocols being developed, which, if you implement them, reduce the quantum threat substantially.
Sounds like such an important topic for executives to be thinking about, because it's the threat's imminent, right? So, I mean, interesting point kind of leading off that, right? So there's on one side, there's the threat to security, as you're talking about. On the other side, there's the opportunity to generate some additional returns through better optimization of collateral and other spaces. What do you think is a better driver for action, the threat or the opportunity? Big open-ended question, but it'd be great to get your thoughts.
I can start. I mean, incumbents usually the incumbents usually have a fear to lose something. They are in the defender mode, and a disruptor, kind of a scale-up, a startup, has nothing to lose, so to say. That they want to gain something. Yeah. So therefore, I think that's more kind of the logic. I mean, who will actually be the new emerging players, just tackling kind of new solutions based on quantum and kind of disrupting the space, yeah. And I think that is kind of a logic which also gives a lot of opportunities and chances for the upcoming quantum tech industry to create new players, yeah, and to disrupt kind of the global pecking order in various industries. If you look in the automotive industry, it was kind of a startup which disrupted actually the incumbents, right? So here, quantum is such a disruption. I think we'll see kind of new players which emerge out of the quantum space, and also, tackle some financial services segments. E.g., I just mentioned blockchain. If you have quantum vulnerabilities in kind of the protocols, and you have to make it, quantum enhanced or quantum secure, might be that you create new protocols based on quantum logic and create kind of new blockchain protocols, which create completely new players.
Interesting. So do you see challenger banks and digital bank, question for both of you, do you guys see challenger banks and digital banks as being adopters of quantum technology in the similar time as some of the larger organizations, or maybe even ahead, or do you see them as kind of adopting it in a bit later?
I probably see them adopting it a little bit later. Look, we're also investors in Revolut, so I know how digital banks work quite a lot, and the priorities that they've got. And as we said, I think the big use cases or the early use cases are where there's going to be a significant opportunity to optimize something or other, right? And so, as Markus said, you're looking at optimizing 2 or 3 basis points, maybe 5 basis points. Then if you've got billions of dollars on your balance sheet, then those 3 to 5 basis points makes a significant amount of money when you analyze it over the year, right? Yeah. And some of the neobanks and some of the smaller SMBs just don't have the problems at the scale right now that makes a quantum solution worthwhile. Now, at some point, it will become a use case that will be commoditized and packaged and deployed at a price point and at an accessibility point where a smaller organization will be able to use it. If I look at other opportunities for quantum, I sit on the board of Glovo, which is in the food delivery space, much like Deliveroo, right, in southern Europe, and they're in 860 cities. You can imagine every day we've got models running, and each of those 860 cities, their models are slightly different. The restaurants are in slightly different places. The weather patterns are slightly different. The drivers are in different locations. Where the food needs to get to is different locations. Different cities have football matches on different nights of the year, right? So if you add all that stuff up, then there's some significant use cases, but that's not going to be worthwhile running in a small city. But maybe when you get to the size of Valencia, or you get to the size of Milan or Barcelona, it's worth it. But is it worth it for a city that's under 1 million people? Maybe not today, but it doesn't mean you shouldn't do it for some of the bigger organizations. So I think it will come down, but as of now, I really think it's going to be some of the large organizations that are going to be looking to take advantage of the financial benefits of those small enhancements to start with that will clearly become bigger over time.
Yeah. As with anything, sorry, go on.
If I may add that, if we have the time, because I was also reading kind of the chat, and there was a question addressed to me, which I could nicely kind of weave in. I also think, the big organization, I mean, they have that big potential. If you have that 1 trillion collateral portfolio, it's such a potential, right? So therefore, the big corporates, of course, I think will move, but for them, there is another aspect, which is relevant. I mean, you might be a kind of a quantum tech startup and have now such great solution, and you offer it, and you think, that is a kind of a home run. They will easily deploy it because you have that P&L advantage, yeah. But then, you have to understand the regulatory environment, the IT security, the IT operations environment where, financial institutions operate in these days. So, how can they migrate? In our case, QMware is accessible via the cloud. How can they migrate an application out of their infrastructure onto a kind of a startup's quantum computing cloud, right? So you have to have a lot of kind of tick marks in your box in terms of your IT due diligence to actually do that as a large bank. And we completely do understand that. So that might come a little bit kind of as an additional challenge to those startups, that you really not only have to be prepared that you have a good solution, but that you can also understand IT operations and now know how to migrate the stuff into a cloud and know kind of the requirements of these banks. By the way, our cloud is completely GDPR compliant and Gaia X compatible out of these respects as well. And the question here was also asked, is you know, what is needed to get started with that, e.g. the collateral optimization case for a bank? Not too much, actually. I mean, you can define this as a kind of small POC, you know, you don't have to tackle the 400 billion at once. Yeah, you start with a kind of 10 billion, 20 billion chunk where you have kind of good data quality that you take and migrate it. Yeah, so nothing really to lose, but a lot to gain. Yeah, and that's kind of the small steps. You get better data quality, you aggregate it more and more, and you see the benefit, and yeah, and you're getting started. So not really a big investment, especially not if you approach it in the way how we promote it. You know, you work with those quantum tech startups and you get the support in designing the algorithm, and you get somebody in who has a machine to deploy the algorithm on.
I think one of the benefits today versus 2 years ago or 4 years ago is, you know, 4 or 5 years ago, going into a big financial institution and asking them to send you their data into the cloud, you would get no. They'd be like, I want an on-prem installation. And then startups would be scratching their heads saying, holy cow, I need to now come and install my stuff in your rack, in your data center. And then over the last few years, banks and organizations have got more comfortable with using a SaaS product, because they've realized that actually, if it's installed locally, they don't get the latest updates. They're always on two versions behind people who did adopt the SaaS product to start off with. And then they've also realized actually from a tech security perspective, you know, they've got, you know, organizations have got more and more comfortable. And that's just for regular machine learning, right? And so there's a lot of AI, ML companies out there today and other companies that are providing services today to banks, where banks are having to send their data outside of their firewall to a third party, and they get the recommendations back. So quantum as the next kind of paradigm can piggyback onto these other shifts of infrastructure and thinking, because to Markus's point, you know, if I'm sitting inside a corporate right now, you know, historically I'd have been saying, okay, I need to build my own quantum team. I need to hire the people. They all need to work for me. I need to have a quantum machine in my data center in Wembley or Watford or outside of Frankfurt, whatever you. But you know, today you're okay sending data out to an Amazon machine or a Google machine. So why would you not be comfortable to send it out to another third-party provider as well? And so these barriers are dropping all the time, that I think, again, will allow corporates to say, maybe I anonymize the data to start off with. There's some fantastic ways of you now anonymizing data to send it out, you know, not necessarily just using homomorphic encryption, but you could just create synthetic data and then unpack it on your side and figure out whether that synthetic data that you sent out has been optimized in a way that you couldn't have achieved yourself. But you need to have the ambition and the kind of the leadership within the organization to be able to experiment. And this is one of the this is a nascent thing within organizations, is how much are they willing to experiment versus other priorities in their roadmap right now. And that's where I think finance is always going to be really challenged, because you've got regulation, you've got existing legacy to new tech enhancements, and then you've got innovation that's going on at the same time. It's always a struggle. And you said earlier, do you chase $10 million of new revenue, or do you chase a solution that's going to save me $10 million in fines? Like, there is no right answer. And that's one of the challenges, I think, in all big organizations, as to where do they spend their human capital, their investment of people next.
Yeah. It's been such a great conversation with both of you guys. I think there's a few questions coming through. So just before we open up to questions that Anna and Paolo will run for us, if you were to leave kind of one piece of advice with corporate executives around this topic, around this space, what would you guys say? Don't
be a Luddite. Give it a go. Look, I think I've in my career, I've sat on the inside and not wanted to look out of the window and just felt that I could do it all best and my team could do it best. And that's not a winning strategy. I think people need to experiment and feel it's okay to experiment within constraints and within a cost structure that makes sense, that doesn't freak out the CFO. And I think you need to look at the solutions that can provide that.
Fantastic.
I'd agree. Quantum is now. Yeah, that's kind of what I would advise. Get started. And by the way, it's such an also inspiring journey. It's such an inspiring, interesting technology. And, you know, I think we all have seen that we need kind of an ecosystem actually to build that new technology, to address it. And I think this is a kind of fascinating time also to collaborate, you know, between large corporates, new startups, to get it done. Yeah. And so therefore, I think it's not only necessary because it's a key technology, but I think it's also a lot of fun to get started.
Fantastic. It's been such a pleasure hosting this conversation, gentlemen. I will hand it over to Anna and Paolo to run the questions. And then, yeah, look forward to discussing further.
Thanks, guys. Yeah, so that's been excellent. Anna and I will just ask a couple of questions. We'll aim to finish on the hour. Anna, did you want to go first with yours?
Yeah, sure. Thank you so much for that. You've given us some fantastic examples of quantum computing's opportunities in finance. What are the other areas that you find interesting?
You mean so I understand the question that this is kind of outside financial services. What are kind of use cases there? And actually, you know, we have built a lot of algorithms, hybrid algorithms, which can be deployed in various industries. I mean, that's the nice thing on it. Yeah, we, for instance, have built a hybrid quantum neural network algorithm which serves for better image recognition. I mean, what can you do with better image recognition? A lot. You can use it kind of for autonomous driving in the automotive industry. You can use it in the robotics industry, but you can also use it in medical diagnostics. Yeah. So therefore, you know, the algorithms serve for various use cases in various different industries. And what we work with right now is, of course, and that's kind of the typical early adopters, chemical companies who have complex chemical simulations to be dealt with, fluid dynamics or so, but also pharma is a big thing. You know, quantum enhanced pharma is very big because all the simulation, the modeling on new medicine can be optimized with hybrid quantum algorithms. So definitely chemistry and pharma are two other early adopters, as well as automotive, due to some of the autonomous driving issues.
Yeah, I'll just echo that. I think as I said earlier, working with Glovo and food delivery and the traveling salesman problem, right? To me, there's a huge amount of inefficiency in society today. We talk about the green economy or the carbon net zero kind of drive. You know, we could talk about new technologies, new solar panels, and new materials, etc. But fundamentally, we waste so much already. We waste a lot of energy. We waste the optimization of the grid. We waste where we position kind of services and delivery around the country. We are wasting now, you know, how we deploy vaccines, right? In terms of, are we optimizing the vaccine into the right location for the right demographic at the right time of the year, based off of, you know, the needs of the continent at the time. So there's plenty of optimization, general optimization solutions that I think are out there before we get into the kind of the rocket science spaces that Markus talks about. I like the ones that I can touch and feel and explain to, you know, my auntie, rather than ones that I need to talk to another physicist about to kind of really get my teeth into. So call me a bit more simple.
And I could imagine one use case on, you know, power grid optimization, because my light actually just went down and it wasn't me. Yeah?
Perfect. Well, then the final question, and then we'll wrap. So you've given some really good examples around how, as senior people, you've managed to engage other senior people on the importance of this. If there's someone listening who is, you know, a more junior manager, and you know, they can't just say, "Hey, let's give this a go," but they need to sort of influence in some other way. Do you have any suggestions to them about, you know, what they should do, maybe learn a bit more before they raise the topic, or raise the topic in a different way? Any advice?
Oh, that's a really tough one. I think we've all been in that situation where we think we've got the great idea, but our boss kind of waves us to one side and says, you know, that's kind of Star Trek or that's Star Wars, my friend. You know, this isn't for now. I think you've got to look at other role models in the industry that you're in. If you're in finance, then and your organizations and look at other organizations that are adopting it and point it out and say, look, no, you may not be doing it, but look what this bank's doing, or look what this insurance company is doing, or I found this article on this JV that's happening, right? And just look for other opportunities to credentialize the movement, you know, and then allow yourself to kind of get into the detail with your manager. But I'd say look for other role models and point them out.
Thank you. Markus, anything to add?
I think that is a good advice. I'd agree to that. Potentially, I mean, you could elaborate a little bit. I mean, it is really also an IP game in the moment, or a race. I mean, you also have to assess what are you risking to lose if you don't kind of own crucial IP on production processes or so, which are crucial to your industry. So I think that should create the necessary level of awareness also on kind of the risk, on the risk side.
Perfect, thank you. So then just before we wrap up, if I could just share with the community what's coming up next Monday to the discussion we had a few minutes ago on the security side. We're actually going to run an event on quantum computing for Chief Information Security Officers. I think there's a general sense that not enough people fully understand the nature of this risk, so we're hoping to have a good conversation there. So please do push your CROs or your CISOs or your IT directors along to that. And then on Thursday of next week, diversity in quantum computing with some colleagues from the National Quantum Computing and Simulation Lab. So 2 events are specifically coming up, and then our usual Quantum Stammtisch and our coding community events. So just it remains to say thank you to Vishal, to Stephen, and to Markus for your time and for your insight. Anna, Emanuele, and myself really appreciate that, and I'm sure everyone who was listening and watching did. We look forward to keeping in touch as this evolves over the coming months and years. Thank you very much, and good night.
Thank you. Thank you.